G'day and welcome back. It's only been 2 weeks since the last video, so you're probably not wondering where I've been, but I'm going to tell you anyway. Here's my Premo lathe. I've done lots of small jobs with it and it's great, but it's time to say goodbye. I wanted something bigger and more modern, and when this Taiwanese lathe came up a year or so ago, I grabbed it. It needs work, but doesn't every used machine? Just the other day my friend Quang bought the Premo from me, and I have to hand it over soon, so there's no time to waste. Let's fix up this big paperweight and make it cut some chips. This blue motor is the original one from the shaper that I had, and the first job is to fit it up to the lathe. The lathe needs to run from a VFD, and the VFD I have only outputs 240 volts, so this motor was better suited. But the new motor is a slightly larger frame size than the lathe is designed for, so we need to make an adapter plate. Let's take this cover off and see what's going on with the pulley. The pulley bore is too small for this motor, and the keyway doesn't match either. The belt is also completely cactus and needs replacing. The plate will sit between the motor and the existing mount, and I'll have screws going through in both directions to hold the motor on safely. But the first step is to get the motor off and give it a good clean. I'm going to miss the old Premo when it's gone. It was a fantastic lathe to me. One of the things that I think is great is when a product title is also a review of the product. So the old Premo lathe really is first class. And of course nice biscuits are exactly that. And crepe paper turns out to be pretty crepe. Have you ever tried to draw a part on a sheet of that stuff? So there was a lot of scrubbing and the cloth was doing okay, but it was not reaching down into the cooling fins of the motor. So I took a leaf out of Mr. Crispin's book and used my brother's toothbrush. I should mention that my brother's got very big teeth. I found that a rag wrapped around a lollipop stick helped to clean out the grooves nicely. Now I'm having a look at the bit of scrap steel plate I've put aside for the adapter plate. It's pretty rusty and pitted. Hopefully I can clean it off and salvage this bit. Off camera I took it outside and used the wire wheel to get it back to solid material. It's really deeply pitted, much more than I thought it would be. But I'm going to persevere and see if I can get this plate usable. Maybe the fly cutter can work its magic on the pits. First step was to make a rectangular shape, just so I can hold it in the mill vise. It had one nominally square corner, so I drew some lines parallel to those and bandsawed those out. I don't know the size of the motor plate at this point. I'm just trying to make some rectangular clean stock. This was a pretty tiring cut, and I can see why people like those roll-in bandsaws. The belt grinder did a good job of taking off the high points until I could get a straight edge to line up with it. This means it will work in the mill vise. I'm leaving out the fly cutting footage. It was pretty ugly, and it wasn't going well. There were just too many pits, which are too deep, and I've already wasted a few inserts on this mill scale and rust. I think this piece of material is too far gone, and if I keep going until it's cleaned up, it'll take all day, and it'll be too thin at the end. So I decided to stop and change tack, and try again with a new piece of steel. Here's the new blank, and I took this outside and used the cut-off disc in the angle grinder to liberate a square from the end. And here in the mill I'm edge milling the new plate to size. Here's Rusty, he's wandering around, wondering what's going on. And here's the plate so far. It's been milled to size and I've taken the corners off on the belt grinder. Now it's time to find the centres of the motor bolt holes. I like to take an outside measurement, then zero the calipers, then an inside measurement, and I halve the result. Then I re-zero and close the calipers. And that's my average measurement, 164mm. I also did the same on the other side, and that came to 140mm. After taking a couple more measurements to work out my corner offsets, I've added those to my finely crafted master plan. The new mill vise has a great feature where you can reverse the jaws to hold large pieces of plate and get access to the whole surface. Just tapping it down with a chunk of brass. Now I'm edge finding the corners. Those corners get spot drilled. Then I'm using a 17/64 drill, which happens to be the exact size for a tap drill for M8. Now I'm countersinking for these flathead countersunk screws. They need to sit flush on both sides so they don't foul the motor plate or the motor. I'm using the new pointer that I made for the mill as a kind of tap follower, since I don't have a real tap follower. It turns out it's dead easy and dead accurate. All I have to do is add a bit of quill downfeed with each rotation, and it's quick and easy, and it keeps the tap perfectly locked into square. So now, essentially, these are studs which the motor will hang on. So let's test out the fit. And the studs sit right in the middle of all four holes. I like to go for maximum adjustability as much as possible because I've got a growing body of data predicting that nothing I make will fit anything else that I make. So the adjustability comes in handy. Now I'm using a level as a straight edge and I'm spanning the driven pulley. I'm projecting a line down to the motor shaft and I'm making sure it just skims the end of the shaft. The pulley is 50mm thick and the available shaft length is also 50mm, so this makes for an easy alignment. I'm also checking for square, which means the belt will track nice and straight and not get too hot or try to ride up and off the pulleys. Now I've got the motor in position, I mark the plate position and remove the motor and clamp it back in the same position. Now I'm transferring the threaded holes through to the new adapter using a transfer punch. I can't quite get the transfer punch into place on the near holes, so I'm just spinning the tap drill by hand through those holes, and this should make a good enough mark. I'm glad I did it this way rather than measuring out, because the holes don't seem square or parallel to anything. They should be because they're for a motor, but anyway, the new plate will be straight and square. Now I'm deepening those punch marks, and I had to be careful to make sure that they didn't clash with the holes coming through for the short studs. You can just see Rusty beside the drill, and I've got a clear chip guard in place to stop chips coming over and giving him a smouldering nose, which would probably interrupt his sleep. Just drilling these out as clearance holes now. The screws will go through here into the original motor mount screw holes, and this way I'm not making any irreversible changes to the lathe. So getting the motor plate lined up, I was pleased to learn that the screws went straight in, no shenanigans necessary. It was all nice and accurate. You don't have much room for error with countersunk screws because they provide a location more so than, say, a cap head screw, which can have a bit of clearance. The taper pulls the screw axis tight to the countersink and also tight to the threaded hole. And if they're not spot on, you end up with screws that don't seat properly and so on. The only trick now is to mount the motor with the studs centered in their openings, and that's not too hard. I used the straight edge again to help me. Exactly the same thing I did before, but this time the motor is bolted into place. And I'm just really verifying that nothing has moved in the process of bolting it down. Although that's not the best shot, those pulleys are lined up. This will just help the belt to track nice and straight. You saw that the motor pulley was too small on the motor shaft, so now it's time to modify that. So I'm just clocking it in, and unfortunately it's a painted surface and it's got some dings on it, so I'm just trying to take an average reading and get it as concentric as I possibly can. This is a 1/100th of a mil indicator, which is more or less like a half thou indicator. And I'm within 1 or 2 tick marks here, I think. I'm also checking the face. The pulley is pushed hard up against the chuck jaw steps, but it doesn't hurt to check. You can't see the dial, but it is running true. As a final check, I'll just switch the lathe on and run a round rod into the groove, which is the working face, and I can't feel any bouncing or vibrating. So this bore has to be opened up from about 19mm up to about 24mm. I'm just using a CCMT insert, and it's extended by about 55mm because I've got to go through a 50mm iron pulley. There's a bit of an interrupted cut because there's a keyway, but that's gone by the time we get to the right size. Now I don't want this to be a press fit or difficult to get on in any way, so I want it to be slightly over the nominal size, but only by about half a B's donger. I think I've got about 1 thou clearance on there, which for this size pulley should be about right. It should go on easily, but not wobble around. The set screw and key will hold it tight in place. It does go on easily enough, with minimal if any play, and I think for a V-belt drive that's absolutely fine. Here's the V-belt, and you can probably see how worn that is. There are a couple of splits in the meat of the belt, and it definitely needs a new one. Now it's time to try on the end cover, to make sure that there's clearance around the pulley, and that looks good. Now I've got to align this grub screw so that I can make the keyway in the right place. And my trick is to use a long screw and line it up with a 1-2-3 block against the jaw. There's some flex in the screw, and so I have to take the average position, and if I can get that screw thread as central as possible, I think we should be good. Then I tend to find the left and right edges of the hole and find the midpoint using the DRO, and then I tend to find the near edge of the hole so I know where to start plunging a keyway. Now I don't have the correct size broach tool for this job, so I'm going to try something new, and I'm making do with what I have. Now this is an Evolute carbide end mill which Live Tools very kindly sent to me to try out, so thank you. And this is the first time I've needed a 4-flute, so I haven't tried it until now. This is a cast iron pulley, and I'm plunging 1mm at a time out of this keyway, and I'm actually plunging beyond where the flutes stop on the end mill. I carefully measure the diameters of the flutes and the shank, and they're very, very close, so I can get away with it. But if there's any appreciable difference, then the carbide end mill would just snap off like a piece of glass. But this did a very nice job. I'm holding on to as little of the end mill as I dare, and I'm plunging as deep as I can reach. So this kind of thing takes nerves of steel, but I've got nerves of aluminium at best. The keyway goes through 2/3 of the pulley thickness, which is ample to transmit the torque. And of course, it's not a square keyway, so I now need to make a custom key. So just as a test, or an exercise, I'm going to try and use the belt grinder to make this key. Normally I would mill it to shape, and if needed I could knock off the corners until it fits properly, but I thought I'd give this a go just to get some practice on the new grinder. Worst case, I can start again. So I need to fashion a key that can go into the keyway with no play. I bandsaw out a notch just to get it to fit height-wise, and then with a bit of refinement, it's a good fit. It's not the prettiest thing in the world, but it will work well. And the way the pulley has to go onto the motor, the key needs to be on the inboard side, which makes it captive, which is not a bad thing. Then I'll do up the grub screw, and after having a look at that and making sure it spins true and without play. Now we're looking at the mechanical brake actuator and the micro switch, which tells the brains that the foot brake is on and to stop sending power to the motor. And when you press it down, you can see here that it drives the spring into one of the mounting screws, and it drives the overlong bit of cable into the cabinet wall. The whole thing is a noisy, flexible mechanism that's not very confidence-inspiring. So the first step was to cut off that mounting screw and stop it from binding and rubbing on the spring. I think it acts as a return stop as well, but because the spring is relaxed at the top of the return stroke, it doesn't really need it. So I'm holding onto this bolt with the Allen key, which is a good way of getting a better grip on the thing and a more consistent grind. Pop it through again and stick the nut on, and now it's the right length. I also want to take off most of the excess cable here. And now we've got no sloppy movement or play. I'm just wedging this screw head for now because I can't get an Allen key in there, and then I'm tightening up from the inside. The micro switch is set up for a normally open operation, but I need to reverse the logic so that it's normally closed. I'm just having a look in here, and yep, it's a normal micro switch. I can move one of these wires to the other terminal and that will reverse the logic. That should do the trick. As I press the pedal, it releases and deactivates the micro switch, which actually closes the circuit, which is what the VFD needs to see to engage the emergency stop function. Now it's working lovely. Time to test it. I've got my meter set to continuity, and when I press the pedal, the circuit closes. Okay, so the cabinet on the back now. This had a lot of very old school electrical gear inside it, and I've gutted that and I'm replacing the lot with a VFD. And when I say I'm replacing it, I mean I'm getting it prepped for my tame Gumtree electrician to replace. I'm going to give this cabinet a clean and make it more pleasant to work on. I did spend some time early on with a multimeter and I figured out what each of the wires did, and I left notes on the front of the cabinet which will make the job easier. I'm going to put a transfer punch through the holes on the rear of this cabinet and then mount the VFD inside. It's all sheet metal though, and the whole thing bounces each time and it needs realigning for each hole. I did that and then deepened the marks with a centre punch. Then I'm popping some 3mm holes through. Now deburring these holes with the old countersink and a drill chuck trick. And I use a 13mm drill bit for the ones which don't have enough clearance for the drill chuck. Now the way I'm going to mount this VFD is on a set of Mexican standoffs. I put screw and washer through from the back, and then the standoffs, and the VFD sits on those. This gives clearance behind for screw heads and above for a bit of airflow. Putting the motor back in place, tightening everything down, and now the electrician has replaced the motor cable with new and added a cable gland, and he's done a nice job. I'm using a nut driver here because I've got poor access to the fixings. Now for another bit of a detour, I'm looking at the top end of the brake system now because it's still playing up. I'm thinking the mechanical brake has worn out brake pads or maybe a wallowed out drum, but looking at it, the pads are nearly new and the drum looks perfectly fine. What I did discover was that the cable is hardly actuating the cam inside the drum, so I think the cable is too loose or perhaps the adjustment has slipped. Anyway, we'll give this a bit of a clean up and a tighten up, and that now works fantastically. I can spin that and press the brake and it's locked. And that brake is also synchronised with the switch as well. Nearly at the end, time to test, so I leave the belt off and put the carriage drive in forward. The motor spins up, great, and neutral, and in reverse, it's doing everything it should do. And that's it. It's been a long time coming, that little project, and I'm thankful to Quang for buying the Premo lathe. It's really kicked me into gear and renewed my enthusiasm for getting this bigger lathe working and making chips. This is obviously just the bare bones, just to get the lathe functional and running, but there will be more on this lathe in the future, and I have some items on order to help modernise it and make it very user-friendly. And as for the Premo, you know what they say, it's better to have loved and lost than to have never loved at all. Thanks for watching, and I'll see you in the next episode.